x equals 1 plus sine t over cos t, y equals 1 plus cos over sine. We need to get y dash in terms of x and y. So let's use the quotient formula then to get the derivatives. So here, dx dt, quotient rule, v times du dx, so sine differentiates to cosine, minus u, 1 plus sine t, times to v dx, which cos goes to minus sine, so that becomes a plus and that becomes a sine, all over v squared. And this cos t, isn't it? So it's cos squared t. What do we have? We have cos squared here, we have a sine squared here. When we expand this bracket, that will be 1. Plus another one, we'll have 2 over cosine squared t. dy dt then is equal to v, so use the product rule again, quotient rule, v du dx, differentiate this, cos goes to minus sine, minus u, which is 1 plus cos, put bracket around it because it's more than one term, times to v, which is sine differentiates to cos, all over v squared. V is sine t, so it's sine squared of t. So that's equal to then. So what have we got here? We've got minus sine squared, we've got minus cos squared. We've got a minus 1 when we expand that bracket. So that would be total up to minus 2 using the trig property over sine squared t. And we used the fact, in both of these we used the fact that sine squared plus cos squared equals 1. So we get that. So now, let's write down dy dx then. So dy dx is equal to dy dt divided by dx dt. The 2's will cancel, so we don't need to write them down. It's minus 1 over dy dt is sine squared, divided by, or times by t dx, so it's times by 1 over this, so it's times by cosine squared over the 2, which we cancelled anyway. Or we can put the 2's in like so there's no confusion. So we end up with minus cos squared over sine squared t. Okay, so what have we got here then? Well, we need a cos and a sine, and we've got these things here. Now the property here, which is quite an interesting property, which I'm going to mention now, is you take the x, 1 plus sine t over cos t. Here, x is equal to 1 plus sine t over cos t, wasn't it? So let's add them up together. Now let's add x plus 1 over x. That's equal to then this 1 plus sine t over cos t. And let's see what we get. Plus 1 over this, which essentially you invert the fraction over the 1 plus sine t. And let's cross multiply the fractions. More than one term, put a bracket. So it's 1 plus sine t squared, plus cross multiply plus cos t squared, all over the denominator cosine t times 1 plus sine t. So here what do we get? We get a 1, and then when you expand this bracket you'll get 2 sine t plus sine squared. We've already got a cos squared, so that can be a 1. So we just write that as 1 plus 1 is 2, and the middle term is all we need to write down, which was 2 sine t over the cosine t times by 1 plus sine t. So can you see top and bottom? There's a 1 plus sine t common. Take out a 2 outside the bracket, and we're simply left with 2 over cosine t. So that was interesting, that x plus 1 over x was equal to 2 over cos t. If we do the same thing for y, so we can replace cos t here by something along here, this line here, x plus 1 over x. So we can rearrange it and put in for cos. Now what about sine? Well, let's have a look at the other term. So y is 1 plus cos over sine of the t's. Also, well, let's have a look at y plus 1 over y then, which equals 1 plus cos over sine, wasn't it? There's y. plus 1 over y, which is sine t over 1 plus cos t, which equals, so let's work this out, cross multiply, we get 1 plus cos t squared, in a bracket squared that is, plus sine squared t, when you cross multiply those two, all over the sine t. And something very similar is going to happen, isn't it? 1 plus cos t in a bracket. More than one term per bracket. So what have we got here? On the top we've got a 1. And when we expand this bracket, we've got a cos squared plus a sine squared, which is also 1. So they'll add to 2. The middle term is all that's left. And we'll get 2 cos t, won't we? Underneath, we've got a sine t. And then we've got a bracket 1 plus cos t. And that's equal to, then take the 2 outside, the 1 plus cos t's cancel, and we'll be left with 2 over sine t. So we can see what tan t is now, can't we? If we divide the one by the other, so label that as 1, and label this as 2. 1 is that one, divided by 2 gives, and we get tan t then. Because if you divide this on the top, the cosine's underneath, this is now divided by this, and it's underneath, so the sine t will swing around to the top. The 2's will cancel, and we'll be left with tan. And on the other side, it was 1 divided by 2, so 1 was the x plus 1 over x. And the equation 2 was y plus 1 over y. So now we can go back to our original problem, remember? Which was here, dy dx is minus 1 over tan squared, isn't it? Minus 1 over, we can write this as tan squared, can't we, to bring the cosine underneath. So dy dx, so dy dx equals minus 1 over tan squared t, which equals minus 1 over this squared. Oops, squared. Okay, so then we can expand this bracket. We'll have y plus 1 over y squared over x plus 1 over x squared with a minus. Fairly happy with that. I'm okay with that, I think. Yeah, I'm okay. Yeah, that looks fine. So we'll leave it in that form. It looks quite tidy in that form, doesn't it?